Hey, what's up, guys? Chung here again. So let's take a look at another biweekly contest problem this time. It's number 1575. Count all possible routes. Okay. So, and you're given like an array of distinct positive integers locations. Okay, where location I represents the position of CDI, and you're also given like a start and finish point like this, and also a fuel. And basically at each step, right, you can move to any city from your current city, of course, not a different city, right? As long as you have enough fuel, right? And then it just asks you to find the possible all the possible routes from start to finish. And the tricky part for this problem, probably that's why it makes it a hard problem, is that you're allowed to visit any city more than one time. Okay, more than one time. More than one time means that you can, let's say you're at finish line here. Let's say for instance, the number two here, right? See, you're at like zero here, but you can keep moving, right? So most of the other like DP, sorry, problem that for this, once you get to the finish line here, finish position here, we simply return, right? We just stop there. But the difference for this problem is that even though you are at this finish line here, you cannot simply return. You have to keep going, right? Keep going until what? Until you don't have any fuel. So that's the difference for this problem. And since I think I already said this is going to be a top-down DP problem. Basically, at each step, right? At each step, you can move to any of the locations, right? Any of the locations. And so the DP status for this is going to be what? The DP is the going to be the location, and the fuel, right? Basically, this location plus the fuel can uniquely identify your current state, which means that if we have seen this location with the same location with the same fuel, and then we can simply use the the previously calculated results. Okay, yeah, and yeah, and for me, this problem, for me, it's like a more intuitive to do a top-down because it just follows, it just naturally follow the steps of the problem. Basically, we start from this start and then we end to this finish line here. Okay. Uh, yeah, cool. So let's try to code these things up here. All right. So uh, DP, right? And location and the fuel. Okay. Basically, that's my state here. Okay. And I'm gonna write the structure here, the template, okay, and return DP, right? So if location and the fuel is in mem, right, then return log, okay. Mm, yeah, and then answer equals to 0, and memorization is to answer return answer. Okay, cool. That's the basically the skeleton of the top-down DP, right? And mm, okay, let me try to finish this one first. Basically, we just for at each step at each location, right? We just loop through all the locations. Okay. Since we have, let me use a current location here. Current location. Okay. and then for location, right? In locations, if the current one is not the same as the location, since it says all the other locations, they are all the integers allocations are different, and we can simply use that. And then answer plus that, right? Because so we have to accumulate, right? Summarize all the possible branches to the current answer, right? That's how we get the final answer, right? Because from this like location, we can go to all the other locations basically, and the DP is gonna be a what? The DP that location plus what? The fuel, right? The fuel minus because from, oh sorry, I think I missed one description here. Basically, every time when you move from the city I to J, right? And you basically you're consuming the fuel, right? The amount of fuel the same as the distance between those two cities. Oh, and one more thing here, the start and finish, it's not the location, it's the index. It's the index of the city. So which means you start from the 3 here, right? And you finish at 8. Yeah, here it's using the index. It's not using like the actual location. And here I'm using the location, not the index. Okay. So apps current location, right? Minus the location. That's the updated field, right? Okay. And now it's the tricky part, basically. So if we can only visit this like city once, then it'll be like a medium problem or even like medium to easy problem. So for that one, basically, what's going to be our ending point, the base case, right? So the first one is the uh, if the fuel, right? If the fuel is smaller than 0, and we simply return what? We return 0, right? Because if the fuel is negative, that means it's not a valid branch. That's why we return a 0. Or if the current location, right, uh, is the same as finish. Okay. So for normal case, like which we only allow to visit that city once, then it's going to be return 1. Okay. But in this case, since you are allowed to visit the cities more than one time, which means we cannot return here. Instead, we should do what? We should do this. We should do answer plus 1 or answer equals to 1. Doesn't really matter because the answer is 0. Okay. So this thing means that, okay, we have already find the answer here, right? But that's not all the possible. That's it. It's not done basically, right? It's not done. So we have to keep going, right? From this, like the example 4 here. Sorry, like example 2 here. We are already at the finish line here, but since we still have some fuels left, okay? That's why we just want to keep exploring, okay? And since the state it's not only the current location, it's the location plus the fuel. Basically, it means that even at the position 0 at the finish line here with the fuel with the fuel with the current fuel here, we can still basically make more routes starting from here. Okay, and so that's why for this problem, the only uh, baseline or base case is when the fuel is like has become too negative. Then we know, okay, we have reached the end of this path. Okay, and yeah, basically this is gonna be our kind of like a base case, but we're not stopping here. We keep going. Okay, so cool. Oh, and also let's do a mod here. So basically now the start point, start and the few, okay? And in the end, we simply return the that mod, right? 10 to the power of 9 plus 7, right? Okay, cool. I think this should just work. Run it. Hmm. Start. Oh, sorry, here. Okay. Since the start is the index, right? I need to convert it into the actual location. Okay. Uh, no. Oh, yeah. Maybe I should have used the index instead of the location itself. Yeah, let's just use index, right, instead of the location. Since when we do the comparison with the finish, we also use the yeah. Uh, so here I'm gonna use this, right? I in range length of the location. Okay. I know what, but here we also need to convert it to like the you know what? Sorry. Let's still use the actual location here. And here when we do the comparison, we also need to convert it right into a fit into the actual location. Okay. So yeah, I think this should work. Mm, start. Okay. Oh, mod. I'm sorry. All right. So let's try to submit. Cool. So, yeah, it's not the fastest one. It's only beats like 50%, but this one to me is like a more like the most intuitive way I can think of this problem. I mean, of course, there could be like a faster ways. Maybe a bottom-up DP will also work. Yeah, but yeah, for this one, I think at least this one works. Okay, and yeah, just to recap, I mean, it's a like standard like DP top-down DP solutions with the current location plus the field as as the state. Okay, and the only difference here is that uh, when we reach the finish city here, we just add the answer plus one, and then we just keep going. Okay, until the fuel has run out, until we have run out of I mean the fuel. So yeah, and then we just loop through all the possible destinations, the other cities we can go, and then we just pass the the rest of the job to the DP problem here. Yeah, cool. I think that's pretty much it is I want to talk for this problem. Oh, and the time and space complexity maybe. So and the time complexity is, let's see, how many sub problems do we have here? Let's see. So, so the number of sub problem, let's say, let's define like the n equals to cities, right? Cities, and m equals to the fuel, okay? So basically, we have like n times m sub problems, right? And for each sub problems, we'll loop through. Uh, we'll do a n here. So we're gonna have like n here. So which makes this solution like time complexity is O of n squared times m. Okay. So the space complexity is the yeah, it's just this memorization, which is the O of n and m, right? That's the total sub problem that we will be storing into this memorization like a hash table. Yep. Yeah, I think that's it. Okay. Cool guys. Thank you so much for watching the videos, guys. Stay tuned. As always, see you guys soon. Bye bye.